All right, good morning and welcome, everyone. Thank you for joining us for another edition of the New England Chapter Connects. My name is Patrick Yo. I am the co-chair for the APWA New England Chapter Education Committee and happy to be here with you today. Our topic for today is leveraging drones for public works projects. Today, we'll explore how drones can assist with public works projects by increasing project accuracy without the cost of traditional land surveys. This is as public works agencies face the challenges of optimizing their budgets, but still delivering high-quality projects. Today's session will demonstrate how drones can provide accurate existing condition data at a lower cost, enhance decision-making and minimize construction issues, track project progress with visual updates, and generate marketing materials to showcase the achievements. Just a couple of things before we get started, though. A special thanks needs to go out to our APWA New England chapter sponsors. Without their support, we could not bring all of the valuable programs and events to our members and the public works community. All chapter events are made possible because of our generous sponsor support. Their continued investment in our chapter is very important, so thank you so much to our chapter sponsors. We believe and hope that you will find the New England Chapter Connect series worthwhile and informative. We started this webinar series in 2020 to help our community stay connected. Your continued attendance over the course of 5 years is a testament that taking a 1-hour break to learn something new still brings value to our community. We're always looking for new ideas and ways to give back to you, so please let us know what you'd like to see for future sessions. This is our 5th session of the 2025 series, and our final session will be the art of making snow. So look out for that, and it will be held on November 13th. You can register for that webinar by clicking on the link in the chat. If you end up missing a session or would like to replay a session for your staff, all of the New England Chapter Connects webinars can be found on the New England Chapter website. Lastly, please visit newengland.apwa.org for more information on becoming an APWA member if you're not already, upcoming New England Chapter Connect sessions, APWA conferences and events, or becoming an APWA sponsor. Presenting to you today is Ryan Hayden. Ryan is a 2018 graduate of the University of Maine with a degree in civil and environmental engineering and is a licensed professional engineer in Massachusetts. After working for 3 years at his previous firm as a civil engineer with a transportation focus, Ryan joined the Apex team as a transportation project engineer in 2021. Ryan specializes in geometric roadway design and construction administration for municipalities across the region. Ryan also led efforts within Apex to establish a drone services program, which has now completed over 50 projects, including base plan preparation, inspection services, and traffic analysis. Now let's get to today's session. Ryan, the floor is yours.
Hi, everyone. Thanks, Patrick. Let me go ahead and share my screen. All right. So, as was said previously, today's presentation will be on how to leverage drones for public works projects. My name is Ryan Hayden. I've been flying drones for a little over 6 years. I've been licensed since August 2019. I have over 300 hours of flight time and operating drones in the field. My projects range from inspection of water service towers and wastewater treatment plants to traffic analysis, base plan preparation, marketing materials, and essentially anything that you can operate a drone with in the public works space. Today's topic will cover 5 main points: the basics of how to use and operate drone technology within the public works space, mapping options available, data accuracy and comparisons between the different options for collecting data, uses within our industry, and then I'll provide a few example projects. So the basics of flying drones within the commercial space, if you will, is that you have to be an FAA, that's actually supposed to be Part 107 SUAS licensed pilot. SUAS stands for Small Unmanned Aircraft System, and FAA offers often multiple times a year, you can take a course that allows you to learn where to find the materials, and they go over what's going to be covered within the exam. A lot of the material is very concurrent with what actual pilots use to operate planes and helicopters as well. The certification has a 2-year timeline before you need to do a recurrency training. There's no cost to do the recurrency training. It's more to make sure that you're up to date with all the new standards. All commercial flying within public works projects, you need to have a visual observer, which can be anyone who can keep their eyes on the drone in the sky, basically. The drones must remain within the line of sight for the entire duration of the flight. And there are special waivers that must be filed for certain types of missions, such as over areas with high pedestrian traffic, after dark and before the sun rises, between dusk and dawn, and within airport no-fly zones or above the LANCE height restricted zones. That is my license off to the right there, just as an example of what it looks like. So you get a certification number and you're listed on the FAA's Registry of Pilots. So for mapping options, there are two main ones that I'm going to cover here. The first of which is photogrammetry. This one is the most commonly used type within public works spaces, mostly due to the less expensive cost of equipment. This photogrammetry essentially is when you take a lot of pictures from an aerial perspective, using a drone that can geolocate those pictures, and they get stitched together in order to create a terrain. And the images being generally 4K or higher quality will often give perspective using shadows and shading to determine what the elevations within the space are. To do photogrammetry, you have to use ground control points to help build the terrain. That's the base for all survey, generally speaking, but it's required for photogrammetry in order to have accurate elevations. And to use photogrammetry in vegetated areas is not recommended due to the fact that you're taking pictures and you can't shoot through over vegetated areas like woodlands. The results produce terrain and images, which can then be used in CAD or other processing softwares to build the surface and from that point build the base plan. This option, a lot of the drones on the market today vary pretty widely, but the industry standard, generally speaking, is about a $4,000 drone at the minimum, up to about $15,000 for some of the nicer options. One very famous example of when photogrammetry was used was for the recreation of, or the reconstruction of the Notre Dame Cathedral in Paris. In 2010, this was flown for aerial photography and photogrammetry to help build and progress the photogrammetry community. And when it burned down in 2019, the images that were taken in 2010 were used directly to help reconstruct it to its historical look. The second mapping option that I'll discuss is LiDAR. So this is light detection and radar sensing or ranging. It's similar to sonar underneath the water. It shoots a large amount of lasers from whatever angle you're pointing it at, and it basically develops a surface based on how long the pulses take to come back. This can perform very well in vegetated areas due to the fact that it's shooting a laser instead of taking a picture. And the results produce only a terrain, so you get no aerial photography, but the terrain must be used in the same way as photogrammetry with ground control points. This option is much more expensive, relatively speaking, with the nicest equipment ranging up to $35,000. But a lot of the drones have what's called a payload, which can be interchangeable. So oftentimes you can get one piece of equipment and have multiple payloads that offer the ability to switch between them. The famous example, or a famous example of LiDAR, is the ancient Mayan ruins in Guatemala, similar to finding ancient cities in the Amazon as well. A group of research students in 2024 were scanning a LiDAR survey that was taken in 2023, which uncovered an ancient city that had been lost to time and overgrowth of the forest. I don't know if there's any questions up to this point. I can jump right into data accuracy if not.
Nothing yet. Keep going, Ryan.
Yep.
Great. So there are types of data that are used within civil engineering that we're all familiar with. Total station survey and GIS are probably the most common. Total station survey being on the ground survey using field equipment, tripod legs, and oftentimes it's the most common and mostly used type of survey. GIS, Mass GIS offers aerial imagery that has created 1 foot or 3 foot contours. But photogrammetry and LiDAR are the two that was just discussed before this. So I'll give you a second to look at the comparisons between them and talk left to right on the screen. So with photogrammetry in open areas, areas where we would generally consider it to be a good option to use, you can expect accuracy up to 1 centimeter and horizontally speaking, and vertically between 2 and 3 centimeters is an average expectation. You obviously need ground control points, as discussed before, and it produces a very high quality image. Oftentimes it's 2.74, that should be centimeters per pixel, and it can be used for engineering design. Generally speaking, for a large an intersection, as an example, you can expect in the millions for number of points that photogrammetry produces. GIS, the accuracy, generally speaking, isn't as high because it's usually flown from a much higher altitude. So it's more of a general accuracy. You can expect 1.5 meters plus or minus based on the national map accuracy standards. Data is also integrated from multiple data sources, so overall reliability is uncertain, and it is best used for providing framework and context for a project and not engineering design specifically. For LiDAR, the accuracy can be as tight as less than 3 millimeters. But for lower end equipment, it can be similar to what you get with photogrammetry. It does require ground control points, as previously mentioned, and it produces a high quality point cloud. This can be used for engineering design, but similar to photogrammetry and GIS, supplemental either GPS work on the ground or CAD work to draw in features is required. Again, if there's any questions, we can pause.
We're good.
Cool. So uses within our industry, I'm going to go through a handful of points here. The first of which is transportation use. This is generally not traffic. It's just ground control or ground transportation purposes. So what we can create from using drone data is surfaces that can help us to delineate water lines and or water paths, I should say, runoff. We can create contour and elevation maps, point cloud and aerial photography, and base plan preparation for use as a in-place survey, if you will. It is worth noting that unless you stamp a survey with a PLS, or unless you have a PLS that can stamp a survey, this is a substitute that can't replicate exactly. However, if you have a PLS that can stamp a survey, we have been receiving surveys as of late that where surveyors are using drone photography and drone photogrammetry in their processes. So by using drones, you are using what the industry is moving towards anyway. We're generally moving away from total station survey unless it's absolutely necessary. Traffic analysis is the next one that I'll discuss. So one of the latest pieces of using drones in the industry that is really cool is that you can do live video feed to a YouTube channel or a website. So this could be used, say for a news station, or you can use it for like presenting. You can see what live traffic looks like at rush hour. You can also partner with video analysis software for traffic counting. There are many out there that we have partnered with already and that are willing to take on the task. So that's a very cool part of where traffic analysis is heading. Asset management is a big part of using drones, mostly because you can pull really quick data. You can have pavement condition analysis from a pre-construction to a post-construction condition. Parking areas are a great one. Building and structure conditions, so looking at bridges, water towers, smokestacks, anything that you can find within the public use or public space. And railroad condition analysis is a really cool one that MassDOT is partnering to advance. They're using drones to help identify places where repairs are needed along the railroad tracks, considering that a lot of the railroad tracks are inaccessible by car. Water wastewater is a fantastic space for the use of drones. Water tower inspections, along with other structures, wastewater treatment plant inspections and monitoring, and base plan preparations as previously discussed. Stormwater uses. So within the stormwater industry, looking at erosion is one of the biggest question marks of the New England coast these days. And we've been partnering with communities to help track, I guess, where the erosion is getting to. As you can see, we from the picture, Gloucester had us come out and take some pictures of the seawall that they just built around their water pollution control facility. We've also looked at flying the drones out in Nantucket as well to help understand what level of erosion they're seeing from a year-to-year basis. And then after disasters as well, I don't know how many of you might remember from 2 years ago when there was some flooding down in the Attleboro area of Massachusetts. There was a bunch of firms were able to get their drones up in the air to highlight where and how much the failures were occurring within the stormwater system. Construction usage is a great opportunity for using drones. Quick analysis for fresh pavement to look at grades is an awesome use for it because you can get a quick surface from it, and then it can show you contour maps within certain programs that you can plug the data into. Uh, Active construction progress photos and videos are a really cool way to use it. As seen in the picture off to the right, we were actively tracking what the smoke levels were around a hot in place recycling project in Newton, Mass back in 2023. And then working with contractors or with stockpile yards within DPWs across the state is a really cool way to understand how much gravel, sand, or any materials are being used within a calendar year. And then finally, marketing. So obviously with marketing, there's a lot of uses. You can post things on social media, post things on your town or city's website, presentations to the public. As I mentioned before, live feed video for either poor functioning existing infrastructure or recent improvements. And then before and after pictures are a really good way to help the public understand what it is that we're doing with the tax dollars that they're contributing to the community. Non-uses within or for drones start with tunnel interior inspections. Drones need aerial space to fly. So again, there are drones that are coming out now where the camera is on top of the drone. So this may be something that advances within the next few years. But as of right now, all drones have a payload that's underneath the wings themselves, and it can't look up through the wings. So tunnel interior inspection is something that still has to be done on the ground. Urban project analysis. So as mentioned before, if you have to fly over people, you must obtain a waiver through the FAA. This is for safety. They don't want, or the FAA has identified that if a drone were to crash over an urban area, that it could, in all likelihood, hurt somebody. Which is the next point, the nighttime work. That's the same reason. If it were to crash or something, then it would need to, you'd be putting people at risk. Also at nighttime, a special camera is needed, but that isn't necessarily a limiting factor. It's more about the safety aspect. FAA no-fly or restricted flying zones need to have either waivers put in or you're not going to be allowed to fly. The obvious example is on an airport. I've actually had the opportunity to fly at Manchester Boston Regional Airport, and they had a runway shut down for the operation, but I would have otherwise not been able to fly the drone if the runway was open. And then, as mentioned previously as well, projects that require a PLS stamp, um, unless you have a PLS that can stamp the plan set, um, you would not be able to use a drone as the base plan. Last checkpoint before the last section here. If anyone has any questions, I can pause.
We do have a comment in the chat. Robert Barone from the city of Danbury says he has a very successful public works SUAS program. They started about we are in year 4 of our program with 3-part 107 pilots, 107 pilots. We operate in a controlled airspace class D requiring LAANC approval for each mission.
Great. Yeah, that's a really common occurrence. LAANC is the low altitude aircraft compliance zone. So a few years ago, maybe about 5 years ago, the FAA decided that instead of saying that within the 10-mile radius around large airports you were unable to fly, they then gave you somewhat of an angle. So they said that as you got closer to the airport, your allowed flyable zone was lower to the ground. So on the outer skirts of the airport, you might have a 400-foot clearance zone, and as you get closer to the airport, it might drop down to 150 or 0 feet. So using the Lance system, that's really helped to not bog down projects and delay them as we want to do them. So I'll jump right into the project examples. These are all within the last 2 years that were completed. The first one I'm going to highlight is Washington Street Sidewalk Improvements Project in Abington, Massachusetts. This was completed for transportation purposes. We had a 0.6 mile project length with an aerial flying limit of about 0.8 miles or about 4,000 linear feet. The aerial survey cost the town about $15,000, and we had about a 1-month turnaround between notice to proceed and the completion of the base plan, which highlights the timeline. Largely when manned ground surveys or total station surveys are performed, there's at least a double, if not triple or longer timeline to getting this product usable and ready for production of the plan sets that we're going to use to give out to contractors. And just to highlight again the timeline on this project specifically, we received notice to proceed in February of 2023, and we had the bid opening for the project was in June of 2023. So in just about 4 months, we were able to go from a notice to proceed all the way to having a plan set in the contractor's hands. This project cost about $5 per linear foot. This was largely due to the width of the area that needed to be flown with all the side roads and tie-ins off of it. A lot of times for transportation purposes, we like to get a little bit further off of the edge of roadway just to make sure that the topographical information that we're gathering within private homeowners' yard space or down side roads is just as tight as what we're finding in the middle of the road. The next project example is the water transmission line upgrades in Johnston, Rhode Island. This is just one image of the project length, but it was at a tie-in location where you can see just the accuracy. Green is the more accurate, red is either buildings or omitted objects. So anything between red and yellow is what you would consider to be like your very accurate data. This project had a 1.7 mile project length. The aerial survey cost about $16,000 to the municipality. And again, we had about a 1-month turnaround between notice to proceed and the completion of the base plan. Now, this was used for water transmission line upgrades. So we didn't have to go nearly as far off of the road to get tight data through the middle. But in that same breath or the same breath there, the road was also a very wide state road. It was very clear. We had really easy flying days, and there wasn't all that many features on the roadway to capture with additional GPSing or base plan preparation. So this project was about $1.80 per foot. The third project example is Lindsay Street in Alborough. This was a water main replacement. The project had a total length of 2.7 miles. And the image that I've selected over here is highlighting that the MBTA has a bridge that goes over their commuter rail line. So in addition to this survey, we had to supplement some of our data to get like a total station right away plot for this area around the bridge. So that's why the cost of the survey was a little bit more, $25,000, but the cost per foot wasn't anything more. We had a 3-month turnaround on this from notice to proceed to completion of the base plan. This included the time for our surveyor to go out and collect the ground information. But this was a very interesting one considering we had to cross the rail line there. And the last project example I'd like to talk about is the townwide water systems upgrade in East Hampton, Connecticut. This was a large scale project that the town approached us for, and essentially they were looking into the idea of installing new water lanes or upgrading existing water mains within the entire town for the most part. Not exactly the entire thing, but the majority of the urban center of the town. So we had a total project length of about 36 miles. You can see on the map to the right, all of the lines in black were lines that we had to go out and get survey for. The aerial survey cost the town about $400,000, which compares to a total station survey quote that we received of about 1.7 million. So by performing this using a drone system, we saved the town over $1 million in funding. There's about a 7-month turnaround between notice to proceed and the completion of the base plan. And that's pretty fast considering how much there actually would or how much time it would actually take for an on-the-ground survey to be completed. And again, due to the large size of this and the amount of time it was going to take to process, this cost a little bit more, is about $2.10 per linear foot. But generally speaking, it's still within that same ballpark. We usually shoot for $1.80 to $2.20 per foot. That seems to be the area of comfort, I guess, where we can get all the data that we want and not provide the clients with too high of a quote. That wraps up my project examples. Thank you. And now I'll pass it back over to Regina.
All right, Ryan, just keep that slide up for a second. And Patrick, you want to jump in, or?
I will, I'll ask the question that I posted to Ryan.
Yeah.
I mean, Ryan, great job. Great examples, first of all. I think it was very informative, and hopefully everyone got some good information out of this. And my question to you, thinking about the communities that are here today, is, are any recommendations that you have for communities looking to start up a SUAS program? Where to start, what the main hurdles might be to successfully start it up? Kind of, I know there's a couple comments from Robert, but any tips and tricks that people may have for people to get going?
Yeah, so I think the biggest hurdle when getting started up with a drone program is the processing side of it. Obviously, buying the equipment, the physical equipment to get out there and getting your license are, I would consider them minor hurdles. But the idea of how to process it, that's the biggest hurdle to get over because it's a brand new program. It's the same as if you're starting to use CAD or ArcGIS, or even if you start using any other program out there that's available for any industry for that matter. I would say that if you're starting a drone program from scratch, the best method probably is to find a partnering firm such as ourselves, or a partnering or a neighboring community that may have their own program, and either work with them to use them as training wheels, if you will, to get you up and running on yours. Or if you determine that it's not worth utilizing or buying your own equipment, then just staying with them as a partner would be my recommendation.
Does anyone have any questions they'd like to ask and come off mute to do so, or you can drop something in the chat?
And Ryan, you can take down that slide.
Okay.
Anyone have any questions? Jason?
Liz just dropped one in, Liz Strauss. What are your most used apps, softwares? She's aware of Aloft and some weather apps, but always trying to learn other reliable sources
Would that be for
in terms of planning flights.
so DJI is the largest, or I guess the most prominent drone provider in the world right now, and they have their own built-in softwares. So if you were to purchase a drone, like right now, I'm flying a Phantom 4 RTK, and the I guess the controller that I have has a built-in screen with built-in programs that are offered through the DJI system. Um, but there are other ones out there. I'm not familiar with any of them off the top of my head specifically. But that largely comes from the fact that I've been using the same drone for 6 years and haven't really had to deviate too much.
Another one based on weather for you. When you're planning flights, Ryan, where do you say no, it's not a good day, whether it's wind, cloud cover or sun, like how does that affect you? How does the weather affect you? And then where do you say no, it's not a good day to go out?
So generally speaking, rain is a no-go. You obviously can't get the equipment wet. Um, and then if wind, it kind of depends on the drone you have. The drone that I'm currently flying will allow up to about 30 to 40 miles an hour comfortably before it says it's too, the drone equipment is smart enough where it'll tell you that the wind is too high and it has to come down. But generally speaking, if I would say the optimum conditions are anywhere, say, less than 80 degrees and above 30. And having some cloud cover is actually really helpful too, because you don't get shadows cast as aggressively. Really sunny days are just as fine for flying the drones, but you might get lapses where you have like really heavily vegetated shadows that are coming over the road or within your data area.
And say you do have to cancel a day, how does that go with the consistency with the getting the FFA clearance for any of the clearances? Is it a pain to switch the day or to have multiple days lined up? How do you go about that and have a just in case kind of clearance for multiple days in a row?
Yeah, so if we have to coordinate with the FAA directly, a lot of times what we'll do is we'll give ourselves a window. So we'll say that we expect the project to take 1 day, and we'll put it in. The FAA has a submission process where you just give a description of what the project is, the timeline, how long you think you're going to be within the airspace, and oftentimes we'll just give ourselves a window of say 3 days for a 1 day planned flight. If it's more than 1 day, oftentimes I'll go at least 2 times, if not 3 times the length that we expect. So if we expect it to be a 2 day mission, a lot of times we'll give ourselves a week and just do a full 5 days. If we think it's going to be 3 days or 4 days, then it's kind of on the fringe of maybe trickling into the next week if you have some rain. And anything more than that, I would go at least a week longer than what you would expect. If you have 5 days, I would go with 2 weeks. If you have 7 days, maybe go with 12 or 14 days.
Question coming from Nathan Buttermore. How do you get other underground utilities on your base plans for water main projects?
So that's a really good question. And that's a really common question that I've gotten internally as the program has been continuing to progress within Apex. Underground utilities and generally speaking, features that are not visible to the eye are going to come from either record drawings or they're going to come from field investigations. Like for drainage and sewer, we can open them up and collect the data for the inverts. But generally speaking, at least with photogrammetry, and I guess for LiDAR as well, you're collecting the surface information. So anything below the surface is not going to be collected with the equipment that you're getting. There's a post-processing time that we account for on every project. Usually that post-processing percentage is maybe 20 to 30% of the total project cost. And that's the time that's spent calling utility owners, going out and field investigating inverts, and then getting those sketched onto the drawing themselves. A lot of times it's really helpful to call in DigSafe before flying as well, even though there's not going to be any physical work done or any construction specifically. it's nice to get dig safe drawn for the whole limits if you can get them out there before the flight, because then it's visible and you can line things up a little bit easier and understand if there's any discrepancies with what you're seeing from field investigations.
Um, I have a question going back towards training and getting comfortable with your flights. Do you have any resources or opportunities for folks that you know of that are, maybe a training, a trainer or certification program that can help people get used to it without having to either go to a neighbor or and ask to use their equipment, or buy their own and then figure it out? And then this follow-up was when you were learning, how long did it take for you to get really comfortable with flying your drones?
Yeah, so I would say that generally speaking, getting into using drones, there's a factor of it of understanding the regulations, which is what the exam and the certification is helping you get. But there's nothing specific to the drones themselves because each one of them is individual. Um, just the same that when you get your driver's license, there's nothing specific to Toyota or other manufacturers. So oftentimes you have to learn as you go. The FAA doesn't have any requirements right now that say that you have to have 50 hours or any amount of hours to obtain the license. So you can get the license, and then generally speaking, it's just about going out there with someone who's seasoned and them being your visual observer. A lot of times, like you can get out there and learn before you get your license if you are allowed to operate a drone as a non-licensed pilot, as long as there is a licensed pilot there as your visual observer. So it's similar to when you're getting your permit or your driver's license. You can drive a car as long as there's a licensed driver in the car um, that will oversee. And then for me personally, um, I lived maybe 5 minutes from the office back when I was first learning to fly, and I lived pretty close to a public park that was outside of FAA restriction zones. So for me, what I did was I would take the drone home after work. I was licensed already. I got the license during the winter period, and then I started practicing in the spring. And I would go to the public park with my now wife, and we would fly in the park just at low altitude or around objects just to get comfortable with the controls and how it's going to function when it's in the air. We tried to go out there in all conditions if we could. We tried to go out there in windy days where it might be really sunny, and we might try to see what that looks like. We tried all the different processes that the drone has to offer because there's different settings you can do. You can set it to pre-fly something, you can manually fly it, you can have it follow you, so you can have it follow a car or a boat if you want to. Um, there's a whole bunch of stuff, and I just went out there and I just tried to get out as much as I could. So when I was learning, I was out there probably twice or three times a week just for an hour a day or something, just to, keep testing things out.
Yeah, that's good advice for folks trying to think about starting a program up, giving time to their staff that are interested to learn and to develop the skills in a public place that's open, not restricted and whatnot. So
Yeah.
that's good to really know.
Yeah.
David Pezza just dropped in a question. Do you have a game plan for replacing and or supplementing your fleet with non-DJI drones as current tariff and customs holdups continue, especially for larger units like Phantom 4 that uses RTK?
Yeah, so this has actually come up recently because of the tariffs and then legislation that's been put in front of a few state houses in the past having to do with non-approved drones, essentially is the way to put it. Um, the equivalent the equivalent drones across the board that are either American made or American partner made um, are just so much more expensive at the current moment. The technology just hasn't caught up to what DJI has to offer. So the biggest hurdle is the cost of it. Generally speaking, the Phantom 4 RTK base model was about $8,000 when we bought it, maybe give or take a little bit. And the equivalent for the American made model that provides the same thing is about 25,000 at the current rate. So it's significantly more expensive, and it would take a learning curve as well. The controls are the same, similar. Again, I'll reference driving a car. You don't get into four different cars and feel like everything's brand new and you have to relearn it. But to some extent, it is a new piece of software with a new, it has a new program that you have to run it through, and it's it's not exactly straightforward to, a one-for-one comparison. There is going to be a curve that goes along with that. Now, with regard to us replacing or supplementing our fleet, we have looked into it, and it is on our radar for the upcoming years as the Phantom series has been, I guess, pulled back. DJI no longer offers the Phantom series; it's been retired. So for us, the next model that we're going to get, we are in the process of planning for it and trying to look ahead at what technological advances are going to come out in the next couple of years, because there are cool pieces of equipment out there that we would love to be able to use. The Phantom 4 is specific for construction use and photogrammetry, so it doesn't have a detachable payload, as I mentioned in one of my slides earlier. But most of the drones coming out today, that are, I guess, what you would consider like your industry leaders, they do have a detachable payload. So you could take off the photogrammetry camera and put on a LiDAR sensor, or you could take it off and put on a methane detector to help identify gas leaks. Or you could put on any number of things. You could put on a night vision camera. So what we're looking at in the future is getting a drone that has the capability of switching out the payload so that we can offer new services as they come about. Another thing that we've been looking into that's really cool is drones for underwater use now too. One thing that we've been looking into, especially one of our clients in the North Shore of Massachusetts, they had us investigate the use of or the feasibility of a boat launch. And it's hard for us to say without, bringing in a scuba dive team or sending a camera underwater to look at what the subsurface looks like there, or understanding what the density of the soils are under the lake itself. But there are drones nowadays where you can have a payload and it goes underwater and it will tell you soil compaction information and like just how firm it will be, using sonar and other really cool up-to-date programs.
Liz Strauss just dropped in a question. What news sources do you use to keep track of drone-related news and to stay in the know?
So one email, or I'm sorry, one email newsletter that I follow or that I signed up for is the FAAsafety.gov newsletter. And I'll go ahead and put that in the chat here. This website is really cool. It sends out probably on average about every other day, maybe every third day they send out. It gives you a whole bunch of links to recent things within the drone industry. That's the main one that I keep up with. There are some other ones that I try to stay involved in. I try to follow Drone Deploy. That's I'm just remember that as we were talking, but that's one that you can fly your drone with. But they have a newsletter as well that you can stay up with. And then Propeller Arrow is a private corporation that offers, again, a newsletter system that you can get information from.
Okay. Any other questions, anyone? You can come off mute or quickly drop one in.
No, I'd like to comment though. Rob Barone from the city of Danbury. Can you hear me okay?
Yep.
Yeah.
So about 5 years ago, P2 offered the introduction to drones. So we were pretty interested in it, and I got my Part 107 4 years ago. And our program has developed into something that we never thought that it would. It's amazing what uses that we use a drone for. We just finished monitoring and videoing. We built a new high school. We monitored the entire construction of the high school with the drone. We started out with a small Skydio, a Mavic Air 2. It was around $900 at the time. And then we upgraded. We have a Skydio. It's an American-made one now because of the issues with DJI X10. Great device, bridge inspection, planning, observation, mapping, building inspection. Yeah, think of this. Think of in our climate too. where you're suffering, a building suffering from heat loss. You use the infrared just to see where your heat loss is. It's unbelievable with this. We have 3 pilots now, but what this device has done for us. And you know what? It's going to be part of everybody's future. So I highly recommend that you really at least investigate it.
Great. And Robert, while we got you, how often do you think your drone is out on the, out working on a day?
Oh, well, during high school phase, we were out once or twice a week. We fly. Again, we were in a controlled airspace, but we have everything, the Lance approval down where we have we get our Lance approval within a day. So even in the controlled airspace, where you're not in a controlled airspace, you can just go out and fly. But you know, we've worked out the whole program where it's very seamless and very successful.
Great. Thank you for the comment, Robert.
Yeah, it's really cool.
Do we have any more questions? Is this up correctly, Patrick?
I think we're good. Yeah, I think, thank you, Ryan, for taking the time today to show us the ins and outs. I think this was very informative, and there was some really good questions that came through here. So, yeah, hopefully everyone enjoyed it. Please take a minute or two to fill out the evaluation form, get the QR code there. There's also in the chat, there's a survey. Yeah, please send, or even send anything that you have thoughts for. There's stuff you'd like to see in this chat, if you want, for future stuff, future webinars. We are very interested in giving you what you want, not just picking things that we think is the hot topic. So, yeah, thanks again, and, please come back.
I'm just putting my email in the chat if they want to for recommendations for future.
I'll drop mine in as well.
I think my email was dropped earlier as well.
Yeah, I did get that in. I'll bring it down one last time for everybody.
Have a great day, everyone.
Thank you so much. Hold on, we'll just get Ryan's email in there one more time. Oh, it didn't go. That's all right. All right. Thank you all so much, everyone.